This is a nice little paper that came out last year in the fall, so September 2022, led by a bright young man, Vittal Hari from IIT Dhanbad, and his guru Subimal Ghosh. Subimal Ghosh is already a star, and Vittal Hari is obviously going to be a star as well. They basically focus on the heat waves in the Indian subcontinent. Even though they talk about north central Indian region, these typically extend into Pakistan, and especially 2022 was a poster child for how extensive and intense and long-lasting these heat waves can be. Of course, I have argued that the 2022 season was dominated by anthropogenic forcing in terms of Arctic warming, and then natural variability like La Nina, which made the heat wave start early, be more intense, and extend further down into peninsular India, which also plays out in the winter, by the way. So some of those comments are coming out now as to why India is so cold so far down into the southern peninsula. Going back to this paper, we are looking here at death due to heat waves. So it's looking at all years. So histogram of mortality due to heat waves here, and you can see that the numbers are not stacked by years, but they are mostly based on frequencies. So heat waves during late May to early June tend to be more frequent, and here we are looking at those, and heat waves during March to mid-May are here in terms of mortalities. So mortalities in the later season heat waves tend to be higher than the early season heat waves, and 2022, as I said, was earlier and lasted longer as a season and extended over a much larger region. So how these are responding to anthropogenic forcing is a separate issue, which this paper addresses by looking at CMIP6 model projections, which we will come back to. So these are total annual heat wave deaths, but then they want to zoom down into the March to mid-May and May to early June heat waves in general for their analysis. And we are looking also at the risk map here, which this group has done for a while. Here they use the definition of risk being a multiplication of vulnerability and the hazard here being the heat wave. Vulnerability depends on a number of socioeconomic factors like per capita income, education of the women, the kind of job they have, the kind of housing they live in, and so on and so forth. And if they then take the years, already you can see that the risk factor is higher here. In the IPCC definition, the risk is defined as vulnerability times hazard times exposure, so there is additional factor there, and I think it has now been modified to also include response. So this definition keeps varying. But going back to TXX anomaly, the maximum temperature for 3 days during this season, you can see that high mortality years have a much higher temperatures here in this region, which is the region of focus. They call it NCI, or North Central Indian region. Looking at the interannual variability of standardized TXX, so this is June TXS anomaly over the north central India, and these are the years where there are heat waves, and some of them jump well over the 1 standard deviation line here in the normalized TXX, and they also mark the high mortality years, and those are these red dots, and then also the El Nino years in terms of these gray-blue dots. They're supposed to be blue, I think, but they end up being gray here. It doesn't matter, but the main argument is in the paper is that El Niños do not explain many of the heat waves, and more than 60%, I think, or 65% are not related to El Nino, but I'll come back to this in a minute about the definition of El Nino here. Nonetheless, you can see that there are significant number of events going from 1951 to 2019 in terms of standardized TXX exceeding the 1 standard deviation, with mortalities being significant. If you look at the composite anomaly of TXX for the same period, you will see that there is a blob here that is much warmer than the rest of India, so that's the focus. And then they do some composite anomalies of SST and surface winds associated with these heat waves, and find that there is a strong signal here in the northeast Pacific to central Pacific, with this specific stretching pattern which is zoomed in here with a maximum amplitude in SST here, with winds blowing into it from the colder regions in the deep tropical Pacific. And this is typically what is referred to as the Pacific Meridional Mode, except that the Pacific Meridional Mode typically tends to be only in the northern hemisphere, but this paper also has a signature in the southern hemisphere in the so-called South Pacific Convergence Zone region. But there are other papers which argue that the El Nino forces a southern Pacific Meridional Mode as well. So the argument then is to say that this Pacific Meridional Mode affects the Walker cell or the zonal circulation in the Indo-Pacific region. You can go and look up my podcasts elsewhere on the Walker cell and also its relation to El Nino. So El Nino podcasts are there separately as well. So be as that may, there is another issue that's not heavily discussed here, is what is the relation between the Pacific Meridional Mode and the warming we generally see here. So this debate has been going on separately, because many years there is warming here and not here. So in that sense, this is now termed the Central Pacific El Nino or the dateline El Nino. Obviously those are all the El Ninos, including the canonical or Eastern Pacific El Ninos and the Central Pacific or dateline El Ninos, are associated with perturbation to the warm pool, so warm sea surface temperature region that is over the Indo-Pacific, maritime continent, convection, and so on, and that moves around and you get warming here, or sometimes only warming here but the cooling persists here. So whether that's an independent mode or whether it's part of the spectrum of El Nino and so on are all debated still very vehemently and vocally. But this connection proposed in this paper also goes through the perturbation to the Walker cell and the maritime continent convection, as we will see in a minute. In other words, the paper particularly tries to focus on mechanisms related to Pacific Meridional Mode, but you may want to do your own investigation as to whether that's the complete story or this story is yet to be told. The analysis includes the diagnostics that we just looked at, and then they do some model sensitivity experiments, as we will see here, and also future projections with CMIP6 array of models. So to convince the readers that in fact Pacific Meridional Mode and the heat waves over the north central Indian region are connected, they regress the Pacific Meridional Mode index, which is something you can read up. It's basically based on a combined EOF of sea surface temperatures and winds, which gives you a pattern like this, without the loading here being so strong. Nonetheless, that regression obviously shows a high coefficient of regression here, which kind of statistically at least argues that the two are related. But this doesn't eliminate, of course, the fact that the West Pacific convection itself is doing this, because you have to basically philosophically decide whether the heat sources which are so strong can force the higher latitudes like the Pacific Meridional Mode, or whether the high latitude or subtropical thing like the Pacific Meridional Mode can perturb the convection and the heat source and then put a footprint into the Indian Ocean and the Indian subcontinent. Looking also at the time series of the Pacific Meridional Mode and the maximum temperature over 3 days as defined for the heat waves, you can see that the correlation is 0.35. It's statistically significant, but of course if you square this, the explained variance is not that high. Nonetheless, you can see that the peaks more or less match despite the lead lag relations and some big mismatches in some years and so on. And then if they look at the model, so this is the observational response in terms of OLR, which corresponds to cloudiness, which can affect the surface temperatures, soil moisture, outgoing long wave radiation at the surface, sensible heat, etc. So looking at the OLR and 850 hectopascal winds regressed onto the Pacific Meridional Mode from observations, you can see some kind of a teleconnection here, especially in terms of the wind anomalies over the Indian subcontinent and Indian Ocean regions, also associated with the wind anomalies here and a divergence over here over the Western Pacific region where the convection center exists. And they compare it to a GFDL model experiments and argue that it looks remarkably similar to the observations. Are you convinced? Well, this is typically how it works. So assuming that the model is doing a reasonable rendition, they then look at the upper level circulation at 200 hectopascal velocity potential regressed onto the Pacific Meridional Mode in the observations and in the model simulations. And again, the argument is that the model does a reasonable rendition. And this is the 850 hectopascal velocity potential regressed onto PMM from observations. What is the point of doing this? Basically, in the observations, you cannot find necessarily these remote links. Some people do it from of course from the reanalysis product. Nonetheless, the argument here is that the model confirms the processes of relating the Pacific Meridional Mode to the tropical lower level and upper level perturbations and the associated wind anomalies and convection perturbations. And the Walker cell is weakened in the positive Pacific Meridional Mode, which produces westerly wind anomalies over the Indian Ocean, which is much more clear here, and that results in changes in supply of moisture, which is mostly from the Arabian Sea, but that happens more in June when the monsoon onset happens. So we'll see in a minute that the June heat waves are related to the delayed monsoon onset and reduced number of rainy days and so on. So this paper keeps moving between I think there are also times compared for March to mid-May heat waves and mid-May to June heat waves, and the mid-May to June heat waves relate to the monsoon mechanisms as well. Okay, so looking here at the CMIP6 outputs, looking at the characteristics of how the June heat waves and the monsoon onset and rainy days relate, you can see that the integrated vertical moisture transports in climatology obviously bring strong supply of moisture to the onset of the monsoon. The Findlater jet or the southwesterly jets gets set up, and you can see the IVT magnitude and the vectors, and IVT regressed onto PMM then tells you that there is an anomaly which is reducing the strength of the southwesterly jet, because the anomalies here are easterly against the westerlies, and there is maybe increased moisture transport from the Bay of Bengal, but nonetheless reduced rainfall associated with the westerlies over the tropical Indian Ocean correspond to composite mean onset dates for positive and composite mean TXX. So the onset date is in general delayed for positive PMM mode and earlier for negative PMM mode, the correlation being significant at 0.45, and the composite mean rainy days over the heat wave region in the north central Indian Ocean are significantly reduced in the positive PMM mode, and that corresponds to warmer TXS as well. So the entire process depends on PMM perturbations to the Walker cell and the resulting impact on the Indian Ocean and the Indian subcontinent. And the argument is further extended to say that there are also Rossby waves emanating from the Western Pacific, but they don't play a significant role, which then relies on the Walker cell perturbation than the remote forcing by waves, and that the impact of the Pacific Meridional Mode on the El Nino itself may not be so important because the El Nino to heat wave correspondence is low compared to the overall number of heat waves. So doing again the CMIP6 analysis to see how the future projections may look like, what they do is they take a number of CMIP6 models and compare against observations and pick a smaller number of CMIP6 models which do a more realistic rendition of the Pacific Meridional Mode in terms of the sea surface temperatures and the standard deviations. So here the contours in B and C represent the standard deviation of the SSTs leading mode against the ensemble members. Okay, so they convince themselves and try to convince the readers that the models that do a good rendition of the Pacific Meridional Mode then say that for all the scenarios in the future, SSP1 2.6, SSP2 4.5 and so on, they see the difference of delta TXX, the heat wave amplitude for the future minus the historic period. So they consider the future as 2065 to 2100, and they argue that if you consider all the models, then the delta TXX is on a larger range, but if you consider just the models that have more realistic simulation, then they indicate an increase in the future heat wave amplitudes, and that's true for all scenarios. So as you know, SSP1 2.6 is a benign below the 2 degree C target, and then this is the middle of the road, and this is the business as usual scenario. And then they also look at delta TXX. Let's see, the figure unfortunately is not very well captured here. I don't know why that happened. Sorry, you can look up the paper for that. But this is basically showing the similar observations have been made even when analyzed projected changes in the average surface temperature or the NCI region. So even without worrying about extreme temperatures as defined here as maximum of 3-day average, even the average increase temperature trend in the north central Indian Ocean show a uptick in the CMIP6 models in a similar way. So you can see the scales here are slightly different, but because here the warming is more than 2 degrees centigrade and the range here is higher from 5 to 6 degrees centigrade, this is more in the lower range and so on. The uncertainty bands are also larger, or the model ranges are also larger here. So the main story is that the Pacific Meridional Mode communicates through the Western Pacific, perturbation of the Walker cell, perturbation of the Indian Ocean, through the Walker cell, and the convection perturbations in the Indo-Pacific region into the subcontinent. And of course the next step is to see if this is the whole story or whether it's the perturbation in the Western Pacific convection itself that is doing this, and whether there is predictability coming from this. If Pacific Meridional Mode can be tracked, and if it shows that it's getting geared up, let's say in the early spring, can you say something about the heat waves in the later part of the spring? Any predictability you can get this way is going to be important. So read up the paper if you want more details. I've obviously always, as usual, made it a brief introduction. So let's leave it here for now, okay?